In this final part of our project, we tried to visualize our data in an interactive way. For this reason, we created some web applications in an attempt to simulate other visualization tools such as Gephi or Neo4j platform. As we can see here, we have created 5 HTML pages. By double-clicking on each of them, a web page is loaded and it opens the browser. Here we can see that our network is represented in a graph format. The technology we used for this, the main technology we use for this development is the JavaScript. And we use mainly the D3.js library and especially the force layout algorithm. As we can see, there is an initial movement in this graph. This is because the force layout has an initial movement before letting the network being stable, and we retain this functionality. In the other networks that we'll see later, we remove this functionality. As we can see, each user, its node is represented by a circle, and the connection between different circles represent that the user is either being followed or it follows the other user. The name of its node is represented in the middle of the circle, but also by hovering, someone can see the name of the user. We've inserted the functionality of dragging each network in a different position. While we do it, the color of the node changes. By right-clicking on each node, we can see that a window appears. This means that we removed the right-clicking functionality of the mouse and we inserted this functionality. By clicking on this show degree button, one can see the nodes with whom this user is directly connected. By clicking on the show all network button, the network returns to its initial appearance. As we can see, we can also move around the network. We have also inserted other functionalities, such as this button with which we can zoom in the network, and this button which helps us minimize the network, the appearance of the network. We have also included this functionality. With this button, we can see how our data are being clustered by using different community detection algorithms. We click on this button and we show drop-down menu being appeared. Here we can see different community detection algorithms. By selecting each of them, we can see that our data are grouped, are clustered in a different format, in a different way. Here, for example, with this community detection algorithm, we see that our data are grouped, are clustered into different groups. We have included all these community detection algorithms. And like that, we can see the different results. Apart from this network, which represents the data for the whole month, we created 4 other different HTML pages. Each of them visualizes the data per week. For example, this network is for the first week, this is for the second, the third, and the fourth. By clicking on this one, for example, we can see that a web page opens. Here we have removed this initial movement of the force layout. That's why it gets some time for the network to be loaded. Here we see that each node, each circle, has a different size. This is because here we didn't select to have the same size to all the nodes as we did in the previous visualization. We selected each node to get the size depending on the number of tweets he does. For example, here we calculated the radius of the circle by getting the number of the user's tweet and divided it by 10. We did this calculation for all the nodes, and like that we're getting this visualization. Like that, we can again drag and change the position of its node. Here we've inserted a framework, the Qtip. It's a jQuery framework, and by using it, we can click on its node, and we can see that in this way, the network, the user's name is represented. By hovering over each node, we can see that some centrality measures are appeared. Here we get, for example, the user's name, the total tweets, the retweets, the degree centrality, the eigenvector centrality, the closeness centrality, and the between centrality. All these are numbers that were calculated in previous steps of our project, and here we can represent them in an interactive way. Again, by right-clicking on its node, we can see the nodes with whom it is connected, and by clicking on this button, we're getting the initial appearance of the network. Again, we have the zoom in and zoom out functionality, and by clicking again on this button, on this show communities button, we can cluster, we can group our data according to which community detection algorithm we select each time. What we added also in this visualization is this option, is the option we can group our data according to whether they are for or against Brexit. Like that, we can see that, we can easily see actually, that many users for this week are positive, are for Brexit, while on the other hand, those who are against Brexit are actually few. Those who are against Brexit are represented with red, whether those who are for are represented with white. By clicking on all these HTML pages, we can see the visualizations per week. I've already done it here. Here we can see for the first week, for the second, third, fourth, and so on. Just by comparing the final functionality of this one that groups users according to their opinion regarding Brexit, we can easily understand that as weeks pass by, those who are against Brexit are fewer actually, and also we can understand that people tend to tweet less during this month. As a whole, these were our functionalities. What I'd like to mention also is that if someone wants to see the code that is behind this application, with right-clicking on each page and opening it, for example, with a Notepad++, can easily see all the code that is being connected, that is being integrated in this application, that was used actually in order to create these applications. Also here we have the data in JSON format, because this was the format that was used for our data for these web applications.